The last section of Chapter 6 talks about trapezoids. It's the entire right-hand side of your property sheet. We're going to fill in that entire side during this video, so have that out, have your notes out as well. So a trapezoid, what do we know about it? It has four sides, just like every other quadrilateral. It has two different types of sides. It has two bases. Typically because the trapezoid is going to be drawn like this, I'm going to call it an upper base and a lower base. It could be on its side. The bases, though, have something special between them. We're going to talk about that on the next slide. And then the two sides, the two that look different, those are our legs. So two bases and two legs. That's the anatomy of a trapezoid. And definition, which is the property up at the top right corner of your trapezoid quadrilateral worksheet, it has one pair of parallel sides. So the two bases are your two parallel sides. And that's the special property, is that when I draw in a trapezoid, I know that my two bases are the two sides that are parallel. So two parallel bases. And then the legs are not parallel. They cannot be parallel, otherwise they become a parallelogram, rectangle, rhombus, or square. Now a special type of trapezoid, bottom right side of your property sheet, is isosceles trapezoid. So let me draw one, and let me draw it the same as your property sheet. It is okay, so I can't flip this right now. Actually I can. Here we go. Alright, so this is how it looks on your property sheet. And one property, first property, two congruent legs. Isosceles trapezoids, think of them like isosceles triangles. The legs in an isosceles triangle are congruent. The legs in an isosceles trapezoid are congruent. And then base angles are congruent. The two angles that touch the same base are congruent, just like in an isosceles triangle, how two angles are congruent. And then one upper and one lower base angle add up to 180 degrees, just like in a parallelogram, that this angle up here and this angle down here add to 180. And then we have diagonals, and something that's special about the diagonals, let me switch colors for a second. The diagonals of an isosceles trapezoid are actually congruent. So we're going to mark those congruent. So have all this down on your property sheet. We should have almost everything filled in. We have one more definition to fill in just a little bit, and that's the median. So example 1. If the perimeter of an isosceles trapezoid is 41, and BC is 9, and AD is 16, find AB and CD. Now because it says isosceles trapezoid, I'm going to set those congruent to each other, and let's call them X. Perimeter is all the sides added up. So X plus 9 plus 16 equals 41. When I go through that, I get 2X plus 25 equals 41. I'm going to subtract 25 from both sides, and I get 2X equals 16. So X equals 8. So our final answer, because X is 8, AB is 8, and CD is also 8. Example 2, isosceles trapezoid again. Our two bases are here and here, meaning these two sides are congruent. Find the remaining angles. So we have to find everything. Now because the diagonals are congruent, we actually have a bunch of congruent triangles. This triangle over here is congruent to this one here. This big triangle MNO is congruent to PON, and then we have the same on the bottom as well. So if this angle over here is 28, that one's 28. If that one's 42, this one's 42. Alright, and we can keep going through this, and then we're going to use all of the triangles that are made by these diagonals to start figuring out the other angles. I'm going to find the bottom part of the cross in the middle, and I do that by subtracting the two 28s to get that this is 124. Across from it's a vertical angle, which is 124. Next to it is supplementary, so I'm going to subtract that from 180, and I get 56. Over here is 56 as well. Now, because these are parallel, since this is 28, its alternate interior angle is also 28, and same on this side. Now these two up here, I need to use a triangle. I could either use these small triangles and subtract those from 180, or I could use the big triangles. Just I have to do 28 plus 42 in this corner. So I'm going to do 180 minus 56 minus 42, and I get that this angle here is 82. On this side also, because it's an isosceles triangle, the left side is symmetrical. Isosceles trapezoid, the left side is symmetrical with the right side, so we get a lot of duplicate angles. Same picture, but we're going to solve something different. Same basis, NP, this diagonal here, is 12. We know ON is 9. I want to find the perimeter of triangle MNO. Oh, and I missed OP is 6. So MNO is this triangle here on the left. It's congruent to triangle PON because they have congruent sides here. This side is congruent to itself, and the diagonals are congruent to each other. So for the perimeter of either one of these triangles, and let me trace the triangle in blue, for the perimeter of that triangle, I take the three sides from the other triangle, 9 plus 6 plus 12. Now our last definition is median. The median is in the middle here, and to find the median, equal to the average of the bases. Because it's exactly in the middle, and it's exactly in the middle so that it splits the sides in half as well, it's halfway between the two bases in size and in actual distance. So let's take a look at what this means. Let's say, for instance, same picture. This definition is what I was writing, just a little bit more formally written here. Let's say, for instance, HJ is 12, and we know LK is 30. The median of a trapezoid is parallel to the bases, so all three are parallel, creating three trapezoids here, the top, the bottom, and then the whole thing. It's 1/2, or average, the sum of the two bases. And half of 42 is 21. Between 12 and 30, halfway in between is 21, so the median length is 21 in this example. Let's try this one. We have a trapezoid, we have a median. If HJ is 32 and LK is 60, find MN. Same as what we just did, 1/2, 32 plus 60, and 1/2 of 92 is equal to 46. Let's write MN because we're going to erase the picture. What did I say it was? MN was 46. Now, let's erase these because we have new numbers, but same picture. Now we have HJ is 18 and MN is 28. Find LK. When you're given the median, we're going to do it like we did when we were given the midpoint and we had to find the other endpoint. What I'm actually going to do is I'm going to find the rate of change. How do I get from 18 to 28? I'm going to add 10. So to get from 28 to this side, I add 10 as well. That's 38. So LK equals 38. Our last example of this video, we have a trapezoid again, same bases. MN is 5x plus 6, HJ is 3x plus 6, and LK is 8x. My goal is to find HJ. I can't do that without finding x. I know that the median is equal to half the sum of the two bases. I'm taking my two bases, I'm adding them together and dividing by 2, and I'm setting that equal to my median. Let's combine like terms. And instead of distributing in the 1/2, I'm going to multiply both sides by 2. Multiplying both sides by 2 gets rid of that fraction. So on the left-hand side, I got 10x plus 12 equals, this goes away, equals 11x plus 6. I'm going to subtract 10x. I'm going to subtract 6. I get x is 6. It wasn't my final question. It's saying find hj. So I'm going to plug 6 in for x. 3 times 6 plus 6 is going to equal 24.